Hello everyone, hope you all are doing good. So before starting today's video, let me tell you that you will get all the solutions in the Telegram group. You can get the link in the description. So let's start today's video. So the question is asking about to find the minimum number of operations required to modify the array such that array elements are in strictly increasing order. So we basically have to find out strictly increasing array. So let's do this. So what is the logic here? So what logic we will apply? We will try to find out the longest increasing subsequence ending at each index first, and after that what we will do, we will subtract this longest increasing subsequence from the size of the array to get the minimum number of operations. So now what is this longest increasing subsequence? So if we So here the longest increasing subsequence is what? It is 1, 2, 3, 6. You can see that 1 is less than 2, 2 is less than 3, 3 is less than 6. But here 6 is greater than 5. So, so what is the length of the longest subsequence here? It is 4. So this is our longest increasing subsequence. Hello everyone, hope you all are doing good. So before starting today's video, let me tell you that you will get all the solutions in the Telegram group. You can get the link in the description. So I've taken one DP array of size n and initialized it to 1. And I also have taken two pointers, that one is I and the another is j. I will be iterating from index 1 to n, and j will be iterating from 0 to I minus 1. So now what? We will find the increasing subsequence for each index I. So what is the increasing subsequence here? It is 1 to. So let's update this to the length of the subsequence. It is 2, 1, 2. Okay. So for 3, let's point our I here, and j will remain there only. J will start from 0. So is 1, 3 an increasing subsequence? Yes, it is an increasing subsequence. So let's update this index. It will be 2. Again, our j will now point out to this index at index 1. This index. So is 1, 2, 3 an increasing subsequence? Yes. So what is the size of the subsequence? It is 3. So let's update this. Now, moving our I here to 6. So is, and again our j will be initialized to 0, and we will iterate till I minus 1. Okay. So is 1, 6 an increasing subsequence? Yes, it is. What is the length of this increasing subsequence? It is 2. So update this 1 to 2. Again, our now j will point to 2. So what is the increasing subsequence now? It is 1, 2, 6. So what is the length of the subsequence? It is 3. Update here. Again, our j will now point here to 3. So what is the increasing subsequence now? It is 1, 2, 3, 6. What is the length of the subsequence now? It is 4. Right? Now moving here. Now our I will move to here, and our j will again get initialized to 0, that is it will point to 1. Now is 1, 5 an increasing subsequence? Yes, it is an increasing subsequence. So let's update this. What is the length of this increasing subsequence? It is 2. Okay, so now moving to 2. Index 2, the value is 2. So what is the increasing subsequence now? It will become 1, 2 and 5. So what is the length of our subsequence now? It is 3. Now our j will move to 3. So what is the subsequence now? It will become 1, 2, 3 and 5. Okay. So what is the length of the subsequence now? It is 4. Okay. So now our j will point to 6. So what will be the subsequence now? 1, 2, 3, 6, 5. Is it increasing? No, it is not increasing. So we won't update now. Let's move forward. That is 4. So our I will now point here. Now, is 1 and 4, 1, 4 an increasing subsequence? Yes, it is an increasing subsequence. So let's update the length now. That is 2. Now our j will point to 2. Is 1, 2, 4 an increasing subsequence? Yes, it is an increasing subsequence. So let's update the value of our DP array. Okay, 3. Now moving to the index 2, that is 3. Now what is the length of the increasing subsequence? It is not length. What is the increasing subsequence now? It is 1, 2, 3, 4. So what? So what is the uh, length now? It is 4. Okay, again, now the j will point to 6. What is the subsequence now? 1, 2, 3, 6, and 4. So is it a increasing subsequence? No. So no need to update anymore. Now, what is the maximum length of the longest increasing subsequence here? It is 4. So our maximum value is 4. And what is the size of array? It is 6. So we will subtract our maximum longest increasing subsequence from this size of array. So it will become 6 minus 4. We will get our answer as 2. See, we are getting our answer. Okay, so now let's start implementing the question, the coding part. So let's take the size first. Now let's take the dp of size n and initialize it to 1. Now we will iterate first from I to n, I equals to 1 to n, and then we will iterate our j from 0 to I minus 1, right? Now what we will do, we will update our dp array with, okay, not update, now we will first check if our nums I minus nums j is greater than or equals to I minus j. What we will do, we will update our dp array. We will find the maximum dp of j plus 1, right? Now we will find out the maxi, that is max element star max element of what? dp dot begin. Now we will return our answer, that is n minus maxi. Let's compile and run. Let's see whether it will give us correct or not. Okay, so why is it giving me this? Oh, j minus j less than I. It won't be j less than I minus 1. It will be j less than I. Okay, so we are getting our correct answer. Now let's submit. Yes, it has been successfully solved. Okay, so let's end this video here only. So if you have any doubts, you can share your thoughts or your doubts in the comment section. Rather, you can join the Telegram group to ask your doubts, and you will get all the solutions there. Moreover, please do subscribe and hit that like button to get more such content and to help me boost my motivation. So let's end here. Thank you for watching.